Hello everyone. Wow, this is probably the latest that I've ever done. It's 1:54 in the AM. Well, we had some issue. Did some data collection today and I have some serious issue. But it's okay. It's okay. Um, so tomorrow the tropical storm will come. It's arriving, and I think the school's closing down, and the train I have to take in order to go to the data collection site is also not running at full capacity, and the last train back is 4 o'clock, 4:30. So I still want to do data collection tomorrow, but it has to be early. So and it's already like almost 2 a.m. How early can it be? That's okay. That's okay. We still have time, and worst case scenario, the hurricane comes and then they cancel. Well, hopefully it's not gonna be too early. So the plan is I will go there, maybe 9 o'clock, and I start collecting data, which will last about 3 hours. Right, the data collection will last 3 hours, and which is fine. 3 hours is fine. If I can be there by 9, then I can finish like 12:01, and I think I still have a train to go back. If I can't, I don't want to think about that scenario. All right, let's just finish today fast and then go to bed. Online stock span. Design an algorithm that collects daily price quotes for some stock and then returns the span of the stock's price for the current day. The span of the stock's price today is defined as the maximum number of consecutive days starting from today and then going backward, for which the stock price was less than or equal to today's price. For example, if the price of a stock over the next 7 days, okay, then the stock span will be 1 1 1 2 number of consecutive days. Okay, let's do 1. That'll be 1 2 3 4. 1 2 3 4 5 6. Gotcha. Into next returns the span of the stock's price given that today's price is price. Okay, so we call next, and then we call next the full prices include today's price of 75 or less than or equal to today's price. Okay, so what do you think? Yeah, you can't just go back every single time. Yeah, that's not gonna work. So we have the result, right? So which means at a certain date, we know how many days going backwards, right? Let's say for 70, right? We don't go backwards, it's 2 days. So we say 2 days is smaller or equal to 70. But I don't know how many is smaller or equal to 60, right? That's the issue. Going backwards and consecutively. I mean, if this is smaller, yeah, if this one is bigger, then that's it. If this one is equal to or smaller, then I'll take whatever this one give me, right? This one will pointing back, and then these will always be under its wins as well, and then looking for this. So we just jump from here, jump back, right? For example, 75, right? We look at 60. 60 says 1, okay, which is just by itself, and I jump back 1, right? And 70 says 2, so I jump back 2, right? And then 80 is larger, so we know, so this is going to be 3 plus this one's 4. 85, this is 4, So we jump back 4. 1, 2, no. Jump back 4, including this one, jump back 4. So 1, 2, wait, jump back 4. Because 60 jump back 1. So we go here. Oh, yeah. 1, 2, 3, boom, 80. 80 is 1, so we jump back 1. So that's 5. And plus it's 6. Okay, so that's how we're gonna at least try to solve it. Tired. Seems to be a theme every night I say, ah man, I'm tired. Every single night. What else can I say? I am tired. Data collection is always, it's not the fun part. The fun part is to do the data analysis, not the data collection. All right, let's do this. So what do we say? We are going to go back. Do we add to it or no? We can append at the end, so it doesn't really matter. Okay, so what we're gonna say is if not price, okay, then self.price. I mean, we can put a 0 at the beginning. No, we put .inf at the beginning. Then everything is fine, right? And then we say I equals len self.prices minus 1. Okay. We say while self.prices I is smaller equal to price, then rest equal to 0. Rest equal to 1. Okay. Rest plus equal to self.prices. Oh, we need a result. Self.dp. Okay. dp is gonna be 0. Self.dp I. Right? When I add that, and I minus equal to self.dpi. Then we go it again. Because I have this, right? So if think eventually, if the for instance, like it's just keep going up, right? And then we go to the last one, it's going to be larger. Then we'll jump out. Then we will return. Ooh, don't return yet. We'll say self.prices.append price and self.dp.append res. Now we're gonna return res. Okay, let's try this. I have one. Yep. You want to submit? I don't have any gana to try another test case. That's right. Okay, that's it. (901) DP solution. ON. Oof. ON. Yeah, if it's like just go down. Nah. I'll go up. Actually, what's the runtime? Oh, I don't know. Because the more jump you do, the less steps you need. Right? And if you want more steps, which means this goes here. So I am very big. The current price is very big. And the previous price will go here. So it's like jagged, right? Jagged just go up, down, up, down, up, down. So if I go down, up, down, up, down, up, down, up, down, if that's the case, then everything goes here, and then it got stopped. I have to do so. Yeah, we can call it ON, where N is the length of self-dot prices. Okay. Monotonic stack. Oh yeah, it is a monotonic stack. Monotonic stack. I mean, what we're doing is the same thing. Because we jump, right? This jump is essentially a monotonic stack. So this is supposed to be O1. So this is essentially, according to the official solution, which this what I did was a king was basically monotonic stack, but implemented with a DP. Yeah, because I have the jump. So this jump is what monotonic stack does. But we have a better solution. I didn't really see how it goes, so let's try monotonic stack ourselves. So this is monotonic stack solution. We don't have to use the DP array. And what's a stack? Okay. Then every time, because we want to know how many is smaller or equal to. So if I get a small one, I'm just gonna keep popping, right? I'm gonna pop until the end, right? I'm gonna keep pop until something is bigger than me. So it's a monotonic decreasing. Yeah, it's a monotonic decreasing. Monotonic decreasing stack. Okay, so now what? Every time somebody comes in, I will pop. But how I still need to keep count, right? I need to keep count. Like which one is the first, which one is, yeah, you have to count. So, and then you just need to count the length of the stack, right? While this is bigger than this, we just pop until I cannot pop. Then I find the difference. So I still need to know self.count, right? I need a count. How can you do that without count? I don't know. Let me just say while price is larger or equal to self.stack -1, while stack and stack.pop. Okay. Overall. No, you know what? I'd like to call it Owen. not a good implementation. Waste of space. Like this one itself is ON. I mean, overall, you can say it's all. I don't like this overall kind of talk. Ooh, you're gonna put price in it, or you're gonna put? Damn. Then it has to be containing two things, right? Well, stack and the price is then this 0. Then stack dot pop. Pop, 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 right? So we cannot pop. Then we say wait, hold on. This and the new one coming in. The count, I can get a count. Because the current one come in, it will be the last one. Because it will pop whatever it can. And it will get this. Yeah, so the current one, so current count equals self.stack minus 1, 1 plus 1. This is the current count. Then I pop, right? Once I pop everything, I say stack. Oh, stack will always, yeah, because I have the infinite in there. So I say stack dot append price and current count, and we're gonna return stack minus 1, 1 minus stack minus 2, 1. Let's see how this one goes. Name stack, oh, of course. Shoot, self.stack. Yep. And I think we do the same thing. Have an answer as 1. Oh, the number gets popped. Yeah, now I'll use this. It's the same thing. Yeah, it's not any faster, but just space. Memory. Okay, that's it. All right. I'll see you guys tomorrow. It's pretty easy actually today. Adios.